I welcome back you all to this mathematics class. We are covering the syllabus of class 12th mathematics students, and I started with chapter 3 matrices, and in my previous videos I have discussed about the basic definition of a matrix and types of matrices. So now we have also discussed exercise 3.1. So now I am moving forwards and I am going to discuss operations on matrices. So we are going to discuss in this video the operation of addition, its properties, operation of subtraction, multiplication of a matrix by a scalar and matrix multiplication. So let us begin with addition. Consider, students, this matrix A. It is m cross n matrix, that is its order is m cross n. Now consider another matrix B, its order is also m cross n. Now you can see that we can add two matrices only if they have got the same order. So first thing that you have to see before you add two matrices is that their orders should be same. That is, number of row of one matrix should be equal to the number of rows of other matrix, number of columns of one matrix should be equal to the number of columns of other matrix. Now after checking the order, let us proceed for how shall we add them. So we add two matrices A and B element wise. That means we add the corresponding elements of A and B. So let us understand this thing elaborately with the help of an example. Consider this matrix A. This is a 3 by 3 matrix. Consider another matrix B. This is also a 3 by 3 matrix. Now since their orders are same, I can add them. How do I add them? So as I told you, we are going to add them element wise. Element wise means this element A11 will be added to the element B11. So minus 3 is added to minus 3 and I get minus 6. Similarly, A12 is added to B12. 1 plus 7 is 8. Minus 1 minus 9 is minus 10. 7 plus 8 is 15. 0 plus 0 is 0. 15 plus 5 is 20. 1 by 2 plus 1 comes out to be 3 by 2, and 3 by 2 plus 2 comes out to be 7 by 2, and 11 plus 3 comes out to be 14. So now you can see, students, this is the sum of the two matrices A and B. Now you can notice one more thing, that if the order of A is if the order of A and B is 3 by 3, then the order of A plus B is also going to be 3 by 3. Now let us discuss the properties of matrix addition. Now you can see that if A and B are two matrices and they have the same order, then A plus B is going to be B plus A. This means commutative law is followed in matrix addition. That means you add two matrices in any order, the result is going to be same. Second is associative law. That means if you have three matrices A, B and C and their order is same, so either you add B and C first and then you add this sum to A, or you add A and B first and then you add C to this sum. Both these results are going to be same. So we can say associative law is followed by matrix addition. Now third thing is, students, additive identity. So what is the additive identity? Identity is identity of any operation is that number with which if we do the operation on a number with that identity, then the number remains unchanged. That, for example, if you take additive identity of real numbers, that is 0, because if you add 0 to any real number, that real number remains same. That is, you can say 2 plus 0 is 2, 0 plus 3 is 3. So this is the meaning of being the identity. So same is the meaning of the identity in case of matrices. So we should have any matrix which can be added to A and A should remain same. So that is 0 is the additive identity. 0 is the additive identity. So if I add 0 matrix to any matrix in any order, either A plus 0 or 0 plus A, then we get matrix A only. So 0 matrix of the same order is the additive identity. Now we move to additive inverse. What is additive inverse of a matrix? if A is any matrix of order m cross n, then additive inverse of A will be negative of A. What is negative of A? Negative of A is a matrix obtained by changing the signs of every element of A. So definitely when you will add A and minus A, you will get a 0 matrix, and hence additive inverse of a matrix A is its negative matrix. Next operation is multiplication of a matrix by a scalar. Scalar means any number. So let A equal to Aij and B equal to Bij. These are two m cross n matrices. As you can see, their orders are same, and K and L are any two scalars, that is any two numbers. So we verify the product, that if we take the product K A plus B, that is the sum of matrices A and B is multiplied with K, it is going to be same as K times A plus K times B. So you can verify. Take the example. A is a 2 cross 2 matrix and B is also a 2 cross 2 matrix. K is any scalar. So if we add A and B and then multiply them by K, the result is going to be 8 plus 2 10K, 5 plus 0 5K, 5 plus 9 15 14K, and 6 plus 3 9K. So we are going to get the same result if we first multiply K with A. So how do we multiply a matrix by a scalar? We multiply every element of A with K. 2K, 0K, 5K, 6K. And similarly, how do we get K, BK, K times of B? We multiply every element of B by K. K, 8K, 5K, 9K and 3K. If we add them, we get the same matrix. So we verify this property. And similarly, we can also very easily verify that if we have two scalars K and L, and if we have to multiply a matrix A with the sum of these two scalars, so it is also going to be K times A plus L times A. So students, you can very easily verify by checking the matrix A and K plus L. Say if you multiply A, so what happens is that K times A, that means you multiply K, every element of A with K, 7K, 6K, 8K, 2K, 4K, 2K, plus L times A, that is 7L, 6L, 8L, 2L, 4L and 2L. If you perform this operation, if you multiply K plus L with every element of A, or if you add these two matrices, the result is going to be same. And the next operation is subtraction. So subtraction of two matrices is done in the same manner as addition. For subtraction also the orders of the two matrices should be same. तो बेटा subtraction के लिए भी order same होना चाहिए, and आप element wise subtraction करेंगे. That means कि A11 को B11 से subtract करेंगे the same way as you performed addition. Now students, we are going to discuss the multiplication, operation of multiplication on two matrices. Now the condition for the multiplication or the product of two matrices A and B to be defined is, now look, you have to see that you cannot just multiply any two matrices A and B. You can multiply two matrices A and B only if number of columns of A should be equal to number of rows of B. आप काउंट कर सकते हैं A में जितने कॉलम हैं, we can count A में कितने कॉलम हैं 1 2, there are 2 columns in A, और B में कितनी रोज हैं 1 2. सो A के नंबर ऑफ कॉलम्स B के नंबर ऑफ रोज के इक्वल होने चाहिए. In that case only we can add the two matrices A and B. I hope this is clear to every student that when the product AB is defined, this number of the order of A should be equal to this number of the order of B. Now students, how do we perform this matrix multiplication? Please look at very carefully. It is not the simple multiplication of any two elements. It has got a method. What is the method? Now see. First before I start the multiplication, let me tell you one more thing. If you multiply two matrices A and B, आप दो matrices को multiply करते हैं A और B, तो आंसर जो प्रोडक्ट है ए बी का ऑर्डर होगा दिस नंबर 3 क्रॉस दिस नंबर 2. दिस इज द ऑर्डर ऑफ द प्रोडक्ट ए बी. सो ऑर्डर ऑफ द प्रोडक्ट ऑफ टू मैट्रिसेस ए बी इज number of rows of A, which is 3, cross number of columns of B, which is 2. So it is clear to us that what is going to be the order of the matrix AB? मैट्रिक्स AB का ऑर्डर होगा 3 क्रॉस 2. इसका क्या मीनिंग है? इसका मीनिंग है कि इस प्रोडक्ट में, प्रोडक्ट AB में there are going to be 3 rows and 2 columns. So we have 1, 2, 3 rows and we have 2 columns 1, 2. So first step is that you write the order and then you write the structure. So now we have written the order of the matrix AB. So I have made 3 rows, you can see, and 2 columns. Now I have to fill these elements. So how many elements I am going to have? A11, A12, A21, A22, A31, A32. I have to fill the values of A11. So what is this? This is the value of A11. A11 is the element of product AB. A12, A21, capital A22, capital A31 and capital A32, these are all the elements of product AB. So how do I fill A11? For that I take, please look it very carefully, I take first row of A, first row of matrix A, and I multiply it with first column of matrix B. So how do I multiply the first row of A with first column of B? Element wise, A11 into B11 plus A12 into B21. So this whole is the first element of first row of the product AB. Now how do I fill the element A12? For that I multiply first row of A with second column of B, that is A11 multiplied with B12 plus A12 multiplied with B22. So this whole, this sum is going to be the second element of the first row of product AB. Now let us come to the second row of this product AB. For this second row, I have to take the second row of A. To fill the second row of AB, I have to take the second row of matrix A. So first I multiply second row of A with first column of B to fill the element A21. How do I multiply? A21 into B11 plus A22 into B21. Similarly, to fill this element, I will multiply the second row of A with second column of B, that is A21 into B12 plus A22 into B22. Okay, this is also done. So now we have to fill the third row. To fill the third row of the product AB, I have to take the third row of matrix A. So I have to multiply third row of matrix A again with first column of matrix B. So A31 into B11 plus A32 into B21. Okay, this is done. Now we move to the last element, that is second element of third row. To fill this element, I have to multiply third row of A with second column of B. It is A31 into B12 plus A32 into B22. So this is how we are going to get the elements of the product of two matrices A and B. Now students, for your convenience, I have written that how you are getting capital A11. Here capital A11 means first element A11 of product AB. So for this you multiply first row of A with first column of B to get the element A11. Now you have A12, that is this element, you multiply first row of A with second column of B. For A21, that is this element, you multiply second row of A with first column of B, and so on. So this is how, by following this algorithm, you can multiply the two matrices and hence the result. Go. Let us take one example of matrix multiplication. I have taken a matrix A. You can see matrix A, the order of the matrix A is 3 by 2, and matrix B, order of matrix B is 2 by 2. So first I have to check whether the product AB is defined or not. Now I explained you that to multiply two matrices A and B, the number of columns of A should be equal to the number of rows of B. So this number should be equal to this number, and it is there. So we can multiply the two matrices A and B. And what is going to be the order of the product AB? the order of the product AB is going to be 3 by 2. 3 by 2, that is number of rows of A cross number of columns of B. So that gives us the structure of the matrix AB. I already know before writing the AB that what is going to be its structure. Its structure will be like this, that it will have 3 rows and 2 columns. So I have made 3 rows and 2 columns. Now I have to fill these elements. Let me tell you a trick to fill these elements. I write the name of this element. It is going to be A11. This element is going to be A12. This element is A21 and this element is A22. This is A31 and this is A32. So when you have to fill A11, you take first row of A and first column of B and you multiply them, because 1 1 यहाँ 1 1 लिखा है तो आप A का भी फर्स्ट रो लेंगे और B का फर्स्ट कॉलम लेंगे और उन्हें मल्टीप्लाई करेंगे. So this is the first row of A, this is the first column of B. So you multiplied 2 with 4, 2 into 4 plus 3 into 5. To fill this element A12, you will take first row of matrix A and you multiply it with second column of matrix B. First row of A, second column of B. So 2 into 3, that is 6, plus 3 into 7, that is 21. Similarly, to fill 2 1, you take second row of A, multiply it with first column of B, that is 1 7 is to be multiplied with 4 5. So 1 into 4 plus 7 into 5. To write this element A32, you have to multiply third row of, this is A22. So to get this element A22, you have to multiply second row of A with second column of B. So this is the second row of A, this is second column of B. 1 into 3 plus 7 into 7. Here you have to multiply third row of A with first column of B. So third row is 4 5, first column is 4 5. 4 into 4, 16, 5 into 5, 25. And for last, you take third row of A and multiply it with second column of B. So 4 into 3 is 12, 5 into 7 is 35. Now we add these elements and we get 23, 21 plus 6, 27, 35 plus 4, 39, 49 plus 3, 52, and then this number is going to be 41 and this number is going to be 47. So this is the product AB. Now students, let us take the same two matrices B and A and let us try to find out the product BA. To find out the product BA, previously I found AB, now I want to find BA. To find BA, I have to check that number of columns of B should be equal to number of rows of A. Is it so? No. B has got 2 columns but A has got 3 rows. That means students, the product BA is not defined. So it is not necessary that if you are finding AB, you will also be able to find BA. Sometimes when AB is defined, BA may not be defined, and sometimes when BA is even defined, then AB and BA are not going to be equal, they may not be equal. Now students, in this example, with the help of this example, I am going to explain you that AB and BA are not equal, where A and B are any two matrices and AB and BA are both defined. So look at the matrix A, it has got order 2 by 3, look at the matrix B, it has got order 3 by 2. So AB is defined because number of columns of A is equal to number of rows of B. So let us multiply A and B. So here I multiply first row of A with first column of B. 1 into 2 plus 4 into minus 2, that is minus 8, plus 3 into 2, 6. Similarly, I fill this column is this element by multiplying the first row of A with second column of B. I get this. I multiply the second row of A with the first column of B for this element, and I multiply the second row of A with second column of B to write this element. So I get this result. You can calculate and you can see this is going to be the result. Now students, let us take B and A. Let us find BA, the reverse product. So the same matrix B I have taken as I have taken above. This matrix B that I had taken earlier, now I am taking the same matrix B here, and same matrix A that I had taken earlier, I am taking the same matrix A here, and now I am finding the product BA. So we again multiply them in the same order, and we first check whether the product BA is defined or not. So number of columns of B is equal to number of rows of A. So the structure of BA is going to be 3 by 3, and hence I have got 3 rows and 3 columns. So to fill this element, multiply first row of B, first column with A. To fill this element, first row with second column. For this element, first row with third column. For this element, second row with first column, second row with second column, second row with third column, third row with first column, third row with second column, and third row with third column. So I do all these sums and I get this matrix: minus 6 to 21, minus 16 to 37, minus 2 to 11. So we can, if we want to compare these two matrices, AB which was 0, minus 4, 10, 3, and BA which is this. So you can very well see that these two matrices, this and this, in no way are they equal. They are not equal at all. It has got its order 2 by 2, it has got its order 3 by 3, and their elements are also all different. So what do we conclude, students? We conclude that the product of two matrices AB is not equal to the product BA, that is, matrix multiplication is not commutative. Now we discuss the properties of matrix multiplication. Suppose we have three matrices A, B and C. So first of all, we have already observed that matrix multiplication is not commutative, that is, product AB is not equal to product BA. Now if we check the associativity, so we shall be seeing that matrix multiplication is associative. That is, if you have three matrices A, B and C, if you multiply them in this order, that first you multiply AB and then with this product you multiply C, or you get the product BC and then you multiply with A this product in this order only, and it is a condition that these products, all these products should be defined. If it happens, if all the products are defined, then AB into C is same as A into BC, that is, matrix multiplication is associative. And the very important thing is multiplicative identity. So what is a multiplicative identity, students? Multiplicative identity of any matrix is that matrix with which, if you multiply any matrix A, if you multiply A with this matrix I, you get the same matrix A. This is the meaning of identity. Identity means that it does not change matrix A. Multiplication of this matrix with A in any order does not change A. So that identity is, that multiplicative identity is nothing but the identity matrix. We have already discussed the identity matrix when we were discussing the types of matrices. So what is an identity matrix? An identity matrix is a square matrix whose diagonal elements are 1 and whose non-diagonal elements are 0. So now students, it may be clear from here that multiplicative identity exists only for square matrices. For non-square matrices, the multiplicative identity does not exist. So let A is any square matrix, so its multiplicative identity will be the identity matrix of second order. Now here, if A is any 3 by 3 square matrix, then its multiplicative identity will be the identity matrix of order 3. So now students, here I end this class, and in my next class we are going to start exercise 3.2. So please keep revising the concepts and be with me.